Good evening, colleagues. My name is Joshua Biarwanga. I'm here with my colleague, Muhindo Mbaraka. Allow us to take you through the EDA for sick blood smears. And then after the EDA, shall also walk you through the federated learning process. That is how different clients collaborate to train models. So first and foremost, we start with initializing the libraries that we are going to use in our EDA. And then next, we are defining the paths that will contain the data set that we are going to do and the EDA on. The next is the function that we are using to load our images. So on top of loading the images, we are converting them to RGB colors. We are also resizing them. The purpose is to have the uniform size amongst all the images. This is done in order to avoid bias within the model or even overfitting. Next, we are loading the images in parallel. So what this function does, it walks through each subfolders within the folders and checks for any file that has .png, JPG, JPEG, and TIFF. So any files that correspond to the above extension is loaded. So we proceed to attach labels to the affected images, assign the label 1, and then unaffected ones, I assign the label 0. And then this print statement, we are printing to ensure that, just to be sure that our images have been loaded. Then this, we are using it to print the samples of the images that have been loaded. So from this, you see we've we loaded 124 affected images and 135 unaffected images. And these are the samples of the images that we've loaded. Next, we are going to do data pre-processing. And the data pre-processing, we're going to do concatenation, shuffling, and normalization. So concatenations, we are going to merge both data set that is for affected and unaffected to have one set of data. Then thereafter, we are going to shuffle these data sets. The reason for shuffling is to have a random rearrangement of images. This is done in order to avoid bias and overfitting within the model. Then we are dividing our images by 255, that is to obtain a number between 0 and 1. And then we proceed to print the shape of our images from this. So we have around 259 images that were loaded, and each of size 128 and each containing 3 colors. The same applies to the label. The label are size 259. So after that, we proceed to split our data into train, test, validation. So we are splitting our data into X-train, Y-temp, Y-train, Y-temp. So X-train will contain the data that you're going to use for training. Then X-temp will contain the data, the set of data that we are going to use for both test and validation. So the splitting is done by, we shall have a test size of of 30% of the data set, and then 70% the data set we are going to use it for training. So this is how the splitting is done. So 70% of the total data set give us 181 images, each having a size of 128, 128, and each containing three colors. That is red, green, and red, green, and blue. And then our validation set will have 39 images, and also same applies to the test set. Then we also proceed to split the data into the number of the clients that we are going to use for training. So this is to ensure that the data set is split evenly amongst the number of the clients. So since we do not have yet a collaboration between different, say, organizations or centers, so we are going to use one computer to simulate the process of federated learning. So the next is we start by loading, starting the server. A server, that is the central point where the client sends their model updates. They only send the model updates, but they do not send the data. The server, sorry. So this is the script that contains the code for the server. So we navigate to the location of where the script is saved. We activate the virtual environment, and then we run without the server. So for the client to be able to communicate with the server, it means that the server should be running before the client can send up. So that's the reason. That's why we are starting with starting the server. So once the server starts, it puts itself in a state whereby it's able to receive the updates from all the clients. So in our case, we've simulated 4 clients, and the server is going to go through 10 rounds. So once the server is up, then we proceed and start our clients. So when we start the client will first establish a connection with the server. So once the connection has been established, then it becomes ready. So the first thing is the client gets what we call parameter from the server. So once it gets the parameter from the server, then that's when it starts its training. So as it trains, as you see from here, the loss and accuracy is being computed. So after the loss and accuracy has been completed, is done for each round. So the client will send this update to the server. So this process is continuous until all the 10 rounds are done. So once the 10 rounds are done, that means all the clients, all the participating clients have sent their model updates to the server. So the server will proceed to aggregate the updates that it has received from all the clients. So as you can see here, this is the fifth round 2, 3, 4. So this goes up to round 10. So once the round 10 is done, so the model computes the loss, the average loss for each round, and also the average accuracy for each round. So our model didn't perform that well. This is because here we use the manual parameter settings. So in the next setup, we are going to do hyperparameter tuning, that is automated parameter tuning, and we see how the model is going to perform. But nevertheless, this model was saved. So what we do is we pick this model, we deployed it. The deployment, we deployed our model as you see, as indicated here. Hold on. So this is the saved model. This is the model which we trained and we've saved it here. So this is the model that we are going to use for predicting, as you can see. So you can observe clearly. So from the dashboard, from this dashboard, see we have right now we have only 8 tests that have been done. And of 8 tests, we have 6 positive cases and 2 negative cases. So you're going to pick an image. Pick an image. That's the image you picked. So after uploading it, and then you analyze. So upon analyzing, to analyze the analysis will tell you whether this image is affected by malaria or not. So from here you can see that this image is affected by malaria. So you can proceed and upload another one. Let's upload another image. So let's upload another image. So in this case, I've uploaded that. So you see also this has been, it also has malaria. So the process continues. If you go back to the dashboard, you can see now the total numbers increased to 10, and the positive cases have increased to 2, negative cases we have 1. So that is our presentation. We welcome any question. Thank you.